page 654, you can highlight your double angle identities. They're on your formula sheet as well. And what's interesting about the double angle formulas is there's one double angle formula for sine, there's one double angle formula for tangent, but there are three different formulas for cos. And all three of them are equal to cos 2 theta. And actually, all three of them are the same, you just rewrite one as something else. So for example, and they have this written right above. Here is one of the formulas for cos 2 theta. That cos 2 theta is always equal to cos squared theta minus sine squared theta. On your formula sheet. So if you ever have cos squared theta minus sine squared theta, you're allowed to change it to cos 2 theta. And if you ever have cos 2 theta, you're allowed to change it to cos squared theta minus sine squared theta. And these can now be used in proofs, just like the proofs you've been doing. We'll get some more new proofs that can use this. Now, if I took this and I decided, hey, do you agree that you could change the sine squared to 1 minus cos squared? And then if I distributed the negative, you would get this version of the formula. And same thing if you started with the formula and said, I want to change the cos squared to 1 minus sine squared, and then I combine the like terms, then I would get this version of the formula. So we have three versions of the formula, but the only reason there's three versions is you're just playing around with sine squared and cos squared and substituting one out. So the first formula here has sine squared and cos squared, but sometimes it's nice just to have cos. So the second formula just has cos squared theta. The third formula, sometimes it's nice just to have sine. So the third formula has sine squared theta. In proofs, we're going to find out that the cos 2 theta, there's one that's going to always be a little bit better than the other two. And we'll see it's actually not that crazy to figure out which one is which. Okay, so let's go to example 1. This is a typical triangle question. In fact, the first part of this sentence, up to the comma, is exactly like questions you've had in Chapter 6 and in Chapter 7. Given angle theta in standard position with its terminal arm in quadrant 4, and cos theta equals 2/5, this is how we have a normal triangle question. What do? You draw the triangle in the quadrant. So it's in quadrant 4. I go back to the nearest x-axis so that I can label my reference angle. And since I know cos of theta is 2/5, the adjacent side is 2, the hypotenuse is 5. Then I could do a squared plus b squared equals c squared and get the square root of 21. So I draw my triangle, I label all of my sides. Now, if I want to find sine of 2 theta, I have to go to my formula sheet. I can't just find sine of theta and double it. The only thing you can change sine 2 theta to is the formula that says it's equal to 2 sine theta cos theta. And again, highly recommend that you memorize all these formulas as soon as possible. You use them again and have to recognize them in AP Calculus. So now that I have 2 sine theta, I don't know what theta is, but I do know what sine of theta is. Look at your triangle. There's our reference angle. Sine of theta is opposite over hypotenuse, and since it's in quadrant 4, sine would be negative. And we already were given that cos of theta was 2/5. Again, in this one you don't know theta, but you know all of cos theta, so be careful with that substitution when plugging it in. And now when I multiply things through, 2 times 2 comes a negative, negative 4 root 21 all over 25. is our answer. Now for part B, it asks us to find cos 2 theta. And here you have your options of 3 different ones. There's 3 different formulas you can use. Technically, one is slightly better than the other ones. And the one that's slightly better is, well, here. First of all, look at all 3 of them and see if you can figure out which one would be the best one to use and why. And I will tell you, all 3 of them will give you the right answer, and all 3 of them are about the same amount of work. But there is one that's considered slightly better. Have you looked at all 3? The one that is slightly better is, in this situation, the one that doesn't use sine. And the reason it's slightly better is I figured out this root 21. Is there a possibility you can make a mental math error? Yes. So the ones that use sine, if you made a mental math error figuring out sine, then you would get it wrong. But cos theta, the only error you can make with cos theta is a copying error. You could write it down wrong. It's possible. But it's pretty hard to do. It says cos theta is 2/5. So when I plug this into the formula, I have the 2. Cos theta is 2/5. So cos squared theta would be 2/5 squared minus 1. Order of operations, I'll square this first. Get 4 over 25 times 2 will give me 8 over 25. How do I subtract? I need a common denominator, so I'll change that 1 to 25 over 25. And I get negative 17 over 25. Theta was in quadrant 4. What quadrant is 2 theta in? Theta's in quadrant 4. What quadrant would 2 theta be in? And it's going to be in quadrant 3. Can you see how the 2 answers we found in A and B tell us that? Because according to our class rule, now I see that cos of 2 theta is negative. Sine of 2 theta is negative. The only place that sine and cos are both negative is in quadrant 3. So 2 theta would have to be in quadrant 3. Questions for practice on this one? Circle number 9.